Alright, we're going to be graphing polynomials, and although I'm a huge fan of graphing things by hand, polynomial graphing, although some portions can be done by hand, really benefits from the use of a calculator. So we're going to have two calculators going here. You're going to have my digital one, which you can see here, and then we're also going to have this guy right over here. The joy of this is I can show you the buttons clearly here, but over here you can see the screen very, very nicely. What we're going to be doing is I want to start with this equation here, something that certainly would not be a lot of fun to graph by hand. So the way we're going to graph this is you're going to go to turn your calculator on, go ahead and clear everything out. So turn the calculator on, and we're going to go to y equals. Now, if there's anything that happens to be in the y equals, go ahead and hit the clear button. While we're at it, go ahead and go to mode. Your mode ought to be function mode. It doesn't matter at this point whether it's radians or degrees, but function mode. Now, while we're at it, let's go to format. So you hit yellow button, then format or zoom. I have coordinates on, grid off, axes on. Usually this is your setup here with everything down the one side. If you actually want to get rid of something, you hit second quit. Alright, second quit gets you out of everything. Let's go to y equals. Let's plug in our equation. So I have 2.4 raised to the. Now for raised to, you would hit this button right here, this little up arrow key. And then you hit cube. Now sometimes depending on your calculator format, it'll look slightly different than mine, but it'll still be doing the same thing. Plus 5x, and again use the xt theta button. Do not use the other x button. Use the variable button, which is found right there. Minus x plus 7/8. And to get a fraction on this, you simply use the division sign. So at that point, you have put it in here and hit graph. Now, I'm going to hit graph in both cases. You'll notice I see nothing over here. I see something over here. The thing is, we're going to have to figure out where are we actually looking. So if I go to zoom, hit the zoom key, and down to number 6, zoom standard. Over here I'm going to hit zoom, and I'm going to hit zoom standard. Alright, now for some reason I'm not seeing anything. Oh, here's why. Because I have neglected to put something in here. I've forgotten an x. Second insert x. I need my variable in there. Okay, so let's try this, see how we do now. There we go. Okay, so we have the same graph going in both places. Now, this case we can clearly see this is a cubic function. Well, it makes sense. Odd power. It's an odd power for your highest power, so it's an odd function. Starts way down here, goes way up here. So odd function, remember, means there's going to be going opposite directions. So an odd function is going to have that general format right there. Now, since this is a positive 2.4, it will rise from left to right. If this were negative, it would fall from left to right. Now, you also notice that it's a cubic function, so we have a maximum of 3 solutions. But looking at our equation, our graph, we only have just the one solution. Now, had a screen freeze here, so 1 second. Alright, back at it. So we've graphed the function. Now what we need to do is we need to figure out, okay, how many solutions do we have? Well, in this case it crosses just once. Crosses just once. I can estimate that, or I could actually find it. To find it, I'm going to hit the second trace button. That brings me to calculate. So second, calculate. I want to find a 0. Now, a 0 is going to be where it crosses the x-axis. So I'm going to hit enter. Now, what we're looking for is it says left bound. Right down here it says left bound. Left bound means you need to put your cursor somewhere to the left of where it crosses. So I'm going to arrow back, and you can see my little flashing dot move back. Now, in this case it's down below, but it's also to the left of the place where it crosses. Now it says right bound. So hit enter, it says right bound. You need to go to the other side. Now you'll notice it crossed the x-axis. The reason it crossed the x-axis is because if you have a 0 in the middle, most of the time it's going to be moving from negative to positive or positive to negative. And if you go from positive to negative or negative to positive, anytime you move from negative to positive or positive to negative, you're going to have to go through 0. Now, that is the intermediate value theorem. The intermediate value theorem says between negatives and positives or positive and negatives, there is a value, an intermediate value, a value in the middle, and that value has to be 0. So you have the intermediate value theorem. It's one of our key theorems in graphing. So, now once we have our left bound and our right bound, it says guess. So we hit enter one more time. And it says our 0 is at negative 2.329. Now you say, well, that doesn't say 0. Well, it's 7e to the negative 13th. So 7e to the negative 13th means 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 places. So you have this, which is approximately 0. So our 0 happens right here at negative 2 comma 0, negative 2.3 comma 0. That is your 0. Now, we also can find another couple of things. We hit second calculate again. We can find any value we want. So let's hit value. And you say, well, x equals what? Well, what if you have f of x equals our equation, and you say f of negative 3. Well, what is f of negative 3? I could put negative 3 everywhere I see x, or I could simply go to my calculator, second calc, value, type in negative 3, and it spits me out the answer. Negative 3 goes with negative 15.9. So that's how you find a value. If I hit second calculate again, I can find a minimum. Where is the minimum? And again, it's going to have you find a left bound and a right bound. The reason it's going to have you find, so second calc, go down to minimum, and it's going to have you find some bounds because there might be multiple minimums. So what we're going to do is we're going to find, going to go to the left of the minimum, going to go to the right of a minimum, and then hit enter or guess. So second calc minimum, and we're going to have to move to the left side of where it's a minimum and to the right side of where it's a minimum, and guess. Our minimum happens to be at y or x equals 0.09. Remember, the minimum will be happening at an x value. Now the same thing can be done for a maximum. Second calc maximum, and we would do the same thing. Left side, right side, enter. So second calc maximum, left side, right side, and guess. And our maximum happens at negative 1.48. So that's finding minimum, finding maximum, graphing. Now, if we go second calculate again, we could find where 2 intersect. So if I had two equations, 3x plus 7, graph, over here, let's go down to 3x plus 7 and graph it. You'll notice it's going to cross here and here and here, and we could use a calculator to find our intersections as well. So we can zoom, usually zoom standard, but if you have to, you can zoom out or zoom in. We can calculate zeros, we can calculate maxes, we can calculate minimums, and we can evaluate end behavior by looking at the graph. So by doing just a little bit of review on our calculator, you can go ahead and do page 309 if you're in Math 116. 3 through 56 multiples 3. That is the homework associated with this portion. So give that a whirl and turn that in.